Welcome to Business Statistics, Chapter 1, the where, why, and how of data collection. In this chapter, you're going to learn some key definitions. What is the definition of statistics, population versus sample, and a number of categories to which we divide data into. These categories actually help us know which techniques we can actually apply to those data and which we can't. We'll also learn the difference between descriptive and inferential statistics. We'll learn about key data collection methods and different sampling methods. In this video, we're going to focus on the definition of statistics and on the difference between descriptive and inferential procedures. Now, the textbook gives you a definition of statistics that goes something like this. It's a collection of procedures and techniques that are used to convert data into meaningful information. That sounds really good, right? What the heck does that mean? So, when we see a collection, we really mean just a set of procedures and techniques here, okay? Procedures and techniques. So you're probably thinking mathematical formula. Well, you're right. Some of the procedures and techniques that we use are mathematical formula. There are other things that we'll do, like look numbers up in tables or use Excel to help us find out certain numbers or calculate things. There's also some techniques that are as simple as just comparing, sort of like you did when you very first learned greater than or less than. Now, we're using this set of techniques and procedures on data, and we're trying to use that data to say something meaningful. So these procedures and techniques are going to allow us to take that data and turn it into something that's meaningful. Now I said, okay, what is a statistic really? Figured you might want to know this. A statistic is really just a number. It's a number that we calculate from a sample of data. So you've done this before actually, you probably just don't realize it. Let's go over here to Excel. This data sheet is called sportshoes.xls. It's available on the course website. This data was collected on Boise State University's campus, and it represents 100 individuals chosen at random. What we've recorded is the age, the income, the number of pairs of shoes they buy per year, the number of pairs of shoes they own, the number of pairs of those shoes that happen to be Nike. So let's stop right there. Let's pretend that we were interested in knowing the average number of pairs of Nike shoes that people in this data set own. Well, you've done this kind of thing before. So I typed over here average pairs of Nikes just to give us a heading for the number we're about to calculate. In Business 101, you would have just typed in equals average left parenthesis and highlighted the data that you were interested in. So we did equals average left parenthesis and highlighted the column that represents the number of Nike shoes that each individual person owns. What did we get? Well, we got a statistic. That 1.85, or the average pairs of Nike shoes owned by the 100 people in this data set, is actually a sample statistic. It's a statistic. We calculated that number from a sample of data. Okay, so I've said here's the textbook definition. It's this huge discipline of procedures and techniques, or it's just a number. Well, actually, both definitions are correct. It is both a discipline and just a number. Okay, so to think about that discipline a bit more carefully, it's really divided into two categories. This business statistics as a discipline is divided into two categories. Descriptive statistics, or descriptive procedures, collecting, presenting, and describing data, and then the part called inferential procedures, drawing conclusions and or making decisions based on a sample of data. Now, what is our goal here really? Convert that data into meaningful information, whether it be descriptive or inferential. Let's go through descriptive and inferential individually here a little bit more carefully. So descriptive procedures involve collecting, presenting, and characterizing data. By collecting data, we really mean how did you get that data to begin with? right? That's really important actually, because how data is collected can affect the results of all of this statistical stuff that we do. So we'll spend some more time in this chapter later on talking about how we collect data and why that's so important. Presenting data. You actually spent a chunk of your Business 101 course developing charts and graphs. We'll do a little bit more of that here in this course. The charts and graphs that you created are a way to present the data. The third part of that is characterizing data, and you've done some of that before. We did that just a moment ago. We calculated a number to describe that data. So anytime we calculate a number to describe the data, we're characterizing the data. Now, what's inferential statistics then? So think about the word infer. I always start back with the roots here. Infer is actually to draw a conclusion based on some evidence and your reasoning. So inferential statistics are really making decisions or statements based on some evidence and some reasoning. So I wrote here, making statements about a population by examining sample results. Okay, let's think about that. Pretend we were interested in the average number of pairs of Nike shoes that the entire population of the United States, the adult population of the United States owns. Well, we're not easily going to be able to ask every single person in the United States how many pairs of Nike shoes they own. But pretend that we could. If we could calculate the population parameter. Notice the alliteration, population parameter. And then we would know the average number of pairs of Nike shoes that the adults in the United States own, all of them. And we wouldn't need statistics, right? That'd be really nice. But here we are. Because we can't ask everybody and get responses from everybody, we ask a sample of the adult population. From that sample, we're able to calculate an average, like we just did a moment ago. 1.85 pairs of Nike shoes in that sample of data. That number is known because we know the sample, and it's called a sample statistic. Now, what do we do with that number? So we can do two things. We can use it for pure estimation, or we can use it for hypothesis testing. So let's pretend that we wanted to just use a number like that for estimation. So let's say that we wanted to know the population weight, the average weight of all college students in the United States. That'd be really interesting. Pretend these gray peoples represent all of the different college students in the entire United States. Now, many of you are freaking out right now at just the thought of getting on a scale, right? Wendy's going to bring a scale to class tomorrow and make you get on a scale. Not really. So pretend the gray guys are each individual college student in the United States. We're not going to be able to get all of them on a scale. But let's pretend that we can get the red guys to volunteer and get on a scale. We're going to weigh them and going to calculate an average. Based on that average, we can say, oh, well, we know this sample of guys and gals have a sample mean weight of, let's say, 155 pounds. Oh, well, then the average weight of a typical college student must be about 155 pounds. That's all estimation is. We're going to use that sample to say about what the population number actually is. Hypothesis testing is a little bit different from that. Hypothesis testing, we have a belief. And we have this belief, let's say the belief is that the average weight of a college student is 120 pounds. Now we're going to use that sample of data to say, is 120 pounds likely the average weight of a typical college student? Or does 120 seem too small or too big? See, we're going to use this sample of data to accept or reject the idea that 120 pounds is the average weight of a college student. So there you go. We've got the difference between inferential and descriptive statistics.